Before we start, don't forget to like and subscribe. It really means the world to me, and I hope more people can learn from the video. Welcome to another series in my YouTube channel, and this time I will be teaching you how to make a simple 2D platformer game in the most simple way. Without further ado, let's get started. We will need two files, one is the HTML file and one is the JavaScript file. If you are using Versus Code, you need to open a live server. For other IDE, you probably need to find another way to start a server.
First, we will set up the head and the body of the HTML.
We will need a canvas element, which will be the element for our game. Now we have imported the JavaScript. The type must be module so that we can use import statements. We will set the width, height and margin so there are no empty spaces around the canvas. In the JavaScript file, we need to first get the canvas element. Now, we will need to get the context of the canvas so that we can actually render stuff on it. Let's console log and see what we will get. It seems like it is working right now. In the next video we will be rendering the player, so stay tuned. Hello guys! Rendering the player on the canvas is quite simple actually. We need to create the class for player. This will be the constructor. Constructor basically means when we create an instance of it, which is a player, we need to pass in the variables that are stated and they will be the attributes of the instance. For example, if we passed in 5 for velocity, the velocity of the player would be 5. If you are familiar with game development, the render and update methods are the fundamentals. Render means draw and update is for checking every action of the player for every time frame. A color must be assigned to fill styles method to specify the color to be drawn on the player. The fill rectangle method basically takes in the x, y, width, and height of the player. Now we will create an instance of the player class and call the render method so it can be drawn on the screen. As you can see, the player is drawn as a pink rectangle on the canvas right now. In the next video, we will apply gravity to the player so it falls downwards when there is no platform below it. In this video, we will see how we can add gravity to the player. First, we will increase the Y position of the player every update. Then, we will create an animate method so the update and render method will keep on running every frame throughout the game. The animate function will be called again after it is finished and this creates a loop. Now we will add in the render and update method so the player will be drawn and updated every frame. Now we will call the animate function. Now the rectangle has its position updated and is drawn, but the previous rectangle is not removed from canvas. We can fix this by clearing the whole canvas when going into the next frame so the old rectangle is removed. Now it is not showing anything because this method must be called from the start. Now it works. In the next, we will implementing key events. Stay tuned. In this video, we will see how we can handle key events. We will add an event listener that is triggered every time a key is pressed. Now, let's check the console and we will see the output when we pressed a key. We will also need an event listener for key released. The key that is released is also written in the console. This short video ends here, and in the next video we will see how we can move the player using the key events. Thank you. In this video, we will see how we can control player movement with keyboard input. If you haven't checked out the previous video, be sure to check out the playlist, link in description. First, we need to declare a variable to check if any key is pressed. Whenever the key is released, it is set to false. Now we need to set the direction of the player whenever different keys are pressed. For example, if the key pressed is D, then the direction will be right. In the update method of the player, we need to check direction of the player and add or subtract X or Y depending on the direction. Now we will check the console. As you can see, every time we press the key, there will be an output indicating that everything is working fine. Now we need to check if other keys are pressed and set the directions for the player respectively. In the meantime, don't forget to like the video and subscribe. Leave a comment if you have any troubles. You can also contact me through Instagram. Don't forget to set the direction to null when the player is being created. Now, I think we should set the gravity so that we can actually control the speed of the player falling, and we don't need to use the velocity variable for it. Let's change this value to gravity so the velocity can be different from the gravity. Now everything should work perfectly as expected. In the next video, we will see how we can add platform for the player to actually land on. Thanks for watching. In this video, we will see how we can add platforms. First, we need to create a new class for the platform so that we can actually set the X, Y, width, and height of a platform. The constructor is almost the same as the player's, but we don't need some of it. We also need the render method as well to draw the platform. Now, we will need to create an instance of the platform, and the X, Y, width, and height of it depends on your preference. And of course, don't forget to call the render method so we can actually draw it. It is drawn now, but it will not stop the player from falling as there is no collision, so we will see how we can implement it in the next video. Stay tuned and stay safe. Hello guys, let's talk about collision detection in this video. This is the logic behind collision detection. Don't worry, I will explain it line by line. In the first line, we are checking if the bottom side of the player is smaller than the upper side of platform. Hence we can deduce if the player is coming from above. For the second line, we are checking if the player continues to fall, the Y position will be larger than Y of value. If it is, then we will stop it from falling. Now, we should see the player stops falling whenever it is on the same Y position as the platform. Next, we need to check the X position so that we can know if the player is actually on the platform. The position of right side of player must be greater than position of left side of the platform, and left side of player must be smaller than position of right side for collision to occur. I will show you what I meant right now. Fourth line is to check right side of player. Third line is to check left side of player for collision. Let's try to make the gravity larger. Now everything should be working fine. Let's test it for a couple of times to make sure the collision detection is perfect. On second thought, let's change the else if to if so up and left or right can be done at the same time. We need to change those as well so multiple keys can be pressed at once. In the next video, we will be changing the jump logic so that it will look more real and obey the laws of physics. Thanks for watching and stay safe. In this video, I will show you how to implement a more realistic jump for your player. Before we actually start, I think we have to first fix the bug in the collision detection in the earlier video. Very sorry for the mistake, guys. Now it is quite good. Now, let's actually start. First we need to create two variables for the player. One is jump to check if the player is actually jumping, and another is the jump count so we actually know which phase of jumping is the player actually at. This might sound complicated, but just follow along. Direction should not be up anymore, but instead we are checking for the jump variable to know if the player is jumping. I think I will just paste in the whole logic for jumping as it is quite time consuming to build it again, but trust me, this is useful for every game projects. I will try to explain one by one. For line 45, we have to subtract by gravity when jumping because the fall is actually being handled by the jump formula. The negative value will be positive when going up and negative when going down, so we will know when to add and when to subtract the Y position. This line full of calculation here actually simulates the shape of graph for quadratic equation. If you have studied mathematics at a higher level, then you will probably know about it. In the else statement, we will reset the jump flag and reset the jump count when the jump is finished. Now let's check and see if it is working. It should be working for you too, and in the next video we will be talking about scrolling. So stay tuned and stay safe. Before we actually start, we need to fix the key released event. W should not affect the pressed variable because it has nothing to do with the movements. Now we will start implementing the scrolling effect for our game. First, we need to set the boundary for our players so that it doesn't run out of the screen. I will set the maximum X position to be 200 and minimum X position to be 100. You can change them if you like. As you can see, now our player cannot run out of the screen, just like a regular platform game. In the scrolling effect, our platform needs to move as well, so we need to change it. Hence, we need to set the update method. In the update method, the platform has to move left whenever our player moves right and right whenever our player moves left, creating an illusion that the camera is moving while following the player. As you always know, the scrolling is always opposite to the player's movement. Don't forget to call the update method for the platform. It seems like something is going wrong and we need to fix it. Maybe we should add the equal sign as well. And of course the platform should be moving following the player's speed as well, not this .speed. Finally, it should work perfectly and I hope it is for you too. We might need more platforms to actually call it a platform game, so in the next video we will do that. Thank you. First, I think we should add color to constructor so we can actually control the color of the platforms when creating it. Don't forget to add the color whenever instantiating a new platform object. Now we will create an array of platforms. It will first be an empty array with length of 4. Then, we will fill it with platforms with random positions and the color of blue. I think I forgot to pass in the correct color when creating the object. Now it is actually blue. Give me some time as I modify the position of the platforms so they look better. You could modify them according to the needs of your game as well. As a side note, math.random times 71 actually means a number from 0 to 70. Now it starts from 20 and to plus 60, which is 80. Maybe change the numbers a little bit, play around with it. I think this is the best settings for me, so in the next video, we will see how we can apply collision to them so we can actually jump on them, so stay tuned and stay safe. In this video, we will try to implement high-precision collision detection for all platforms in our game. First, we need to create a new variable which stores the player's current jump distance. It is calculated using the formula which we have created earlier. We need to substitute the variable with the formula below it so we don't need to change the formula everywhere. And now we will plug in the logic for collision that we have created here, but don't copy yet. I'm not really sure that it will work, but we will try. If it doesn't, we will try to fix it afterwards. And yeah, it doesn't work when jumping, so we need to fix it. After a while, I actually created a new logic to detect the collision at a higher precision so that the player does not pass through the platform when the jump distance is very large. It's quite complicated, but just follow along. This should be gravity as well. This loop actually checks every pixel of distance and see if the player passes through the platform or not, and not just the whole distance. Great, so now we will check it out and see if it works. Yeah, and now it should be working fine. This might not be the best way, but everyone has their own way of doing this, so feel free to play around with the logic. And I forgot to mention, I just added all the platforms together so it will be easier to check the collisions. Time to remove this as well. Great, it's working fine. Here's more demo. So, in the next video, we will see how we can add image to platform. Thank you. In this video, I will show you how you can add images to platform. As you can see right now, I have created an assets folder and I will put the image for my platforms in the folder. The assets will contain all the medias that we need for our game. Let's find the assets folder and move the image into it. Now, let's take a look at the image. It looks good enough to be the platform of our game. We need to set a new variable onto class to store the image of the platform. Now, we can actually comment out these lines as we don't need to draw rectangles anymore. We will be using the image instead. We will use the draw image function instead to draw our image for our platform. We will now create a function called createImage so that whenever we want to create a new image, we can pass in the name of the image. It will then be set as the source of the new image instance. Whenever we want to use the image, we can take it from the image variable that is returned. We will now create an image using the function that we have just created. The returned image is stored in the platform image variable. So now, we should actually pass it into the constructor. We need to add it to here as well. As you can see, the images are rendered now and now they replaced the boring platforms that we used to have. As you can see, my player is floating right now. This is because the image is not long enough to cover the long platform which acts as the ground. If you want, you can look for a longer image or expand this image to fit your need. In the next video, we will see how we can add a background to our game. Thanks for watching and stay safe. In this video, I will show you how to add a background. First, download your preferred image and add it to the asset folder. Great! Now let's start coding. Let me find a place to add my image using the createImage function. Same as the above line, we will now create a variable called backgroundImage. Now, let's look for a sweet spot to create a class to handle our background image. We will call it generic_object. Same thing, let's set the constructor. We will need to set the X and Y position and of course the image. Now, it's time to create a new instance from the class. Of course, we need to set the X, Y, and image. We need the render method as well to actually draw the image on the canvas. Let's just copy it from the platform class. The background image is somehow not drawn. Let's check the console, no errors. I think I forgot to call the render method. My mistake. We are actually using map method now because it is an array. Weird, it is still not showing up. Let me check it for a while. I think I should make this uppercase for convention purpose. I think this is the wrong part. The C variable does not have X and Y, so we need to set it on ourselves. Great, now it is actually showing. It is an image of a blue sky, better than nothing. We should move this line upwards so that the background is drawn first and the player and platforms can be drawn in front of the background. Perfect, it is now looking quite good as a platform game. Before we end, I would like to change the width of the platform to follow the width of the image so that we don't need to adjust it with the image every time. We need to add a few lines of codes here. I guess that's all for this video. We will implement parallax scroll on the background, so stay tuned. In this video, we will see how we can apply parallax effect when scrolling the background so that it actually looks more mesmerizing. We need to add update method to the background so it actually moves in the opposite direction when the player moves. We can't make it follow the speed of the player because this would not create a parallax effect, so instead we must make it way slower, such as a speed of 1. We now need to call the update method for the generic objects array. Everything should be good, and let's check if it works as we expected. Seems like there is a problem here. There is some white space, so we need to fix it as well. Let's minus the x-coordinate so that it starts from more left and the white space can be filled up. I think 30 should work the best for me. You can play with your number as well too to see which suits you. In the next video, we will add death scenario so that the game restarts whenever the player falls out of the canvas. Thanks for watching and stay safe. Hello guys, in this video we will add death scenario so that whenever the player falls out of the screen it will die and restart. For instance, the game will not restart when the player falls out of the screen and the game just stops there. Before we actually start, we still need to fix the problem of the white space around the background. Let's make the offset 60 for now. Well, maybe we need a larger number like 100. Okay, great. No more white space. Now, let's actually start coding for the death scenario. First, we need to check if the player is out of the canvas. The player's y-coordinate will be larger than the height of the canvas. We will first log something on the console to see if it is working. There's no output on the console. Sorry, it should be y-coordinate, not x-coordinate. As you can see, the message is logged on the console. Great! Now, let's remove this part and call another function called init, which we will create afterwards. It restarts everything in the game, including the coordinates of the player and the platforms. And when we start the game for the first time, we need to call it as well to generate everything in the canvas.
Now, we need to create the init method. We need to wrap the parts where we create instances of the classes such as the player and all the platforms.
And of course, we need to change from constant to let because the instances are recreated and updated when restarting. We need to declare the variables above the method as well. It should be working as expected right now. In the next video, we will be adding Sprite to our player, so stay tuned and stay safe. Thank you. In this video, we will see how we can add sprites to our player, which changes when it starts to move or when it stops. Before we actually start, I think we need to concatenate the asset's path to the source in our createImage method because it is constant, and so that we don't need to write it every time when we are calling it. So, now, we can remove the asset's word whenever we call the method. Now, it still works like before, but we have saved us some time. Now, I'm showing you all the sprites that I have found on the internet to be used as our sprites for the player. I have downloaded the jump, standing, and running sprites. You can find your preferred sprites on the internet as well, but if you want to use mine, I will provide the whole source code soon, which includes the assets. Now, let's start coding. We need to add a new variable in the class of player, which is the sprite. The sprite variable will be an object. It has keys which are for standing, jumping and running respectively. The values, of course, are the sprites, and we will get them by using the createImage method. For now, I will try out the idle and running sprites first. We will comment these lines first as we no longer need them. We will use the drawImage method, but the parameters are different this time. It will need to know where to start cropping because our sprite's image is an image of different stages of animation. This might be complicated for you, must just follow along. We need to use 12 because this is the width and height of one sprite in the image. The last few parameters are x and y position on the canvas to draw the image and the width and height. We need the new variable, which is current frame, to know which frame is the player currently in, to know which stage of animation we need to render. Now we need to increment the current frame by 1 and reset it once it hits the number of sprites in a full animation. Sorry, this should be image, but the sprite variable, and we need to specify which key of the sprite variable to use. Now, let's fix the error that we are having here. I think I forgot the extension just now. Sorry guys. We need to create a new variable to set the current sprite the player is using as well, and it is defaulted to the idle sprite. Now, when the player is moving to the right, the current sprite should be the running sprite. Let's copy and paste for the left movement. For jump movement, the current sprite should be jump. Now, we need to do the same process for the jumping sprite. When the player is jumping, there will not be an animation because there is only one sprite, and we need to reset the current frame as well as we need to restart the animation for walking and idle once the player lands. Now, the animation is looking fine, but there is a glitch where there is a split second where the sprite is not rendered, and we will fix it afterwards. This should be current sprite. We should change the height and width to 12, which is same as the height and width of Sprite. Looks like the player does not change from jump sprite to idle when landing, and we need to fix this. When the W key is released, we need to set the sprite back to idle. Now I guess it is almost perfect. When the player is moving the left, we need to flip the sprite as well, and I will show you how you can do this in the next video. For the small glitch, we set the frame to reset when it is larger than 10 as the maximum number of sprite in an animation, and 11, and we to reset it once the 11th sprite is drawn. Hello guys. This might be the last video of the series, and I will show you how to flip the sprite, and this might be not the best way as it is expensive to flip the sprite, and you can make it easier by creating a new sprite for movement in an opposite direction. However, in this tutorial I will still show you how to do it if you are interested in doing so. First, we need to check if the direction of the player is left.
We need this method as well, but we will need to change up a bit afterwards.
First, we need to save the original state of the canvas that we are drawing on. Then we need to scale the canvas to the original size, but in the opposite direction. After that, we need to restore the previous saved canvas, but the sprite that was flipped is still persisted.
We need to make these negative, as well as the position of the scaled canvas has already changed to negative as well.
Seems like the player always faces to the right when it stops, and we need to fix this. Let's comment out this, and it should work. But now the background and platforms move as well even when the player moves, and we need to handle this problem. To fix this, we can check to see if the A or D button is being pressed, and if none of them is being pressed, the position of background and platforms won't change. Great, now this looks like a good game to be played and ready to be deployed, and I am very grateful if you have been following this whole series. So, don't forget to subscribe and leave a comment or contact me if you have any problems. If you need help in deploying, please do leave a comment and I will make a video about it. Thank you all, and I will see you in the next series.